Hello and welcome, ladies and gentlemen. This is live rehearsal and the recording session from Studio Lab at Doga, a growing cancer production, working title. I'm mveddylive, your host. I had an update for this part. I'm your host. Learning game development, but actually general development. Day 7 Godot, and in day 7 I'm going through on the official Godot docs for version 4.3, getting started, chapter, section, step by step. And I went came to my first script. That's where I need to go. So in the beginning, day 1, 2, 3, 4, I was kind of speed running this, and I found that approach lacking. So I said, hey, let's go in better pay attention in detail to these important bits about intro steps, introduction. I'll take just one moment here. Warm up. Yeah, I'm warmed up. So what I got used to doing is using the Windows magnifier, so I can zoom in to the subject for you also to see. Sometimes the screen moves unpredictably. Actually I can predict it, but so that's why I move it a little bit, center it. So, creating my first script. In this lesson I will code my first script to make a Godot icon turn in circles using the GD script. So my approach, just to point that out, is use the vanilla. Before growing, bloating the project, I want to learn the basics. The basics and actually the vanilla stuff, because in the previous session, going through the step by step, I've learned, actually got familiar with the fact that one Godot as a single executable app. Here is the whole installation folder for Godot, just a zip, unzipped. Here is everything. I downloaded a zip, unzipped it, and additionally downloaded the export template to publish the game on different platforms. So it supports exporting a project, supports Android, iOS, Windows, Linux, and web-based or browser-based games. And the Godot itself is this single executable. This console is I didn't use it yet, didn't need it, but it's practical in case when we learn the terminal commands like talk directly over the API exposed with the engine. One can use it for creating scripts, custom scripting, and running the scripts from the terminal without the user interface of the engine. So to close the point that I was saying is this one executable holds everything, documentation and so on and so on. You can see about that more in the previous stream. Day 6, as I realized that there is a built-in documentation. I'm so being drawn to the fact to show you, but it's already recorded. So let's go with the learning back on the learning track. So they assume I have a programming foundations that I've done. In day 5 and day 6 I went through the whole learning from zero Godot script programming language, let's call it like that. Very good course. There is a hosted web app to learn the fundamentals of GD script with live interactive demos. I'm ignoring completely C# because it requires additional tooling. I don't want it. My approach is to learn to use the GD script so I can create as much as possible logic in the code that I'm guessing it will provide better performance than building a game with visual tools. And first step is create a new project. My project should contain one picture, the Godot icon, that is usually provided by default. I need to create a sprite 2D node to display in the game. In the scene doc, click the other node button. Cool. So I will create a new script. I need to browse and jump to the learning 4.3. I'm in the right folder. I'll just jump one out. I don't use the default C drive and my documents. That's why I need to go a bit leeway around. Or what's the expression? I need to go this way. So I'll create this mach per first script. Select parent folder, create and edit. What I'll do now, I will double check. I need to zoom out. And I will double check in the folder what actually happened. So in learning project, I expected my first script project to be created here, but I still need to get used to the project creation workflow when I use the custom path for the project directory. And I'm supposed to add a other mode. Sprite node. Sprite 2D. But I will double check that. Not this, but browser. I need to create a sprite 2D, so I want to be clear with this on this learning path. No, this time, no more shortcuts. I want to avoid confusion when my project, hypothetical project, grows. How are the files and procedures? How the project grows? Where are the references? What's going on with the assets? Scripts, scenes, and so on. Sprite 2D. In the scene doc, click the other node button, type Sprite 2D. I'm at that point in the search bar. Yes, so anime Sprite 2D. Sprite 2D node, okay. It should have it. Make it so. I need to get this not showing so I can use the browser behind for reference how this should be aligned. Because I'm zoomed in using Windows magnifier, and if I go too close to the screen edges, the viewport will move. Like for example, now I got it. I came too close, but I'm using the web page in the background to. Yeah, cool. So my scene now contains this thingy. And if when I switch back to the browser and follow the instructions, a Sprite 2D node needs a texture to display. In the inspector on the right, you can see that the texture property says empty. To display Godot icon, click and drag the file icon.svg from file system doc onto the texture slot. So sprites, the images they show are referred to as the textures. Let me do just that. So this is the thing. Sprite 2D is selected right here. Enable my highlighting left, right clicking, left, right, actually left, right clicks, so they're showing blue and yellow, and keyboard control double tap highlights the mouse, so I can direct your attention what I'm doing. I don't have a plugin that shows the keyboard strokes, printing on the screen keys that I'm pressing, but during this process I avoid using shortcuts. It's better at this point to, so I'm moving the icon to the slot texture where it's saying empty. I've done it. Can I just... Yeah, cool. This is cool. But next, a sprite 2D needs a texture. Okay, that I've done. I can create sprite 2D nodes automatically by dragging and dropping images on the viewport. Then clicking the icon in the viewport to center it in the game view. Creating a new script, so I'm also supposed to do this action. Select this move. Sprite is selected already. Select move and move it to the center. Viewport, center, shift, mouse, middle mouse button or wheel as a button to move. Now I'm zooming in to frame for us to center the viewport, because theoretically game viewport shows infinite development landscape, let's call it like that. But actually this area, this thin line starting from here, is actually, this is the 0,0 coordinates, xy 0,0, and this is the viewport size, like the game resolution, let's say. And if I zoom on this to fit the game play area into the viewport here, development viewport. Okay, it's cool. Now I know that also the move tool also selects when I click something, an element in the viewport, in the scene. It's centered. Creating a new script. To create and attach a new script to our node, right click on Sprite 2D and select Attach Script. That's not new for all of us that are here from the day one, as that operations I performed several times during tutorials in day 2, 1, 3, up to 4. Attach new script. It allows me to select the script language and file path among other options. Change the template field, this field in the new script node. Actually, attach node script, new script to attach to the node to object empty. Change the template field from node default to object empty to start with a clean file. Leave the other options set to their default values and click the create button to create the script. So object empty. Path, it will be in the root of the project. This is important to point out when having more scripts, more scenes as the project grows. It would be good to create subfolders, subdirectories to organize scripts and assets. Ignoring the instructions for C#. I ignore C#. Not just that I kind of, so I can port the development on Linux. That's the thing, or any other platform that doesn't support tools, C# tooling. That's the thing. I want to be able to just grab my project folder and continue on any other platform without the dependencies for C# libraries. In average, all our devices, computers are fast enough today to run mostly all, provide good performance for all scripting tools, library compiled libraries, binaries, whatever. So I'll here now in this step supposed to add attach a script. I'll leave the name as it is, just instead of using the template for the script, I will use the object empty and hit the create. And here is the script. So the scene now, the viewport changed to script mode, and if I click here on 2D, I'm back into the like a gameplay viewport or workspace or user interface or rendered scene rendering 2D scene rendering preview of this projecto. Back to the instructions, follow the steps. The script workspace should appear with your new script. Sprite2D GD file open and the following line of code. Yeah, I've seen that line of code. That's generic for the extend Sprite2D. Every GD script file is implicitly a class. The extends keyword defines the class. The script inherits or extends. In this case, it is Sprite2D, meaning our script will get access to all the properties and functions of the Sprite2D node, including class it extends, like node2D, canvas item, and node. A note in GD script: if you omit the line with the extends keyword, your class will implicitly extend the reference counted, which Godot uses to manage your application's memory. Cool. Inherited properties include the ones you can see in the inspector doc, like our node's texture. By default, the inspector displays a node's properties in title case with capitalized words separated by a space. Okay, inspector nodes displays a node's properties in title case. In GD script code, these properties are in snake case, which is lowercase and with words separated by an underscore. That's good to distinguish and remember. To better understand the code in the future, I can hover over any property's name in the inspector to see a description and its identifier in the code. Okay, there is the like interactive pointing to interactive reference pointing, or to the from inspector from. Okay, so let's make one thing clear here. This is what I was concerned the whole time. That's why I wanted to go through these steps learning. What they're saying is that my script here and the inspector, so my script is attached to this node, and it is a part of the development process visually in the user interface of the editor, and it exists, and it's listed here as a resource or asset. And here is the script file in the file system for the project. Content of the script is here, and the inspector showing interactively the properties of a selected node. And inspector uses capital case, while code uses snake case, sprite 2. So I guess it's saying that script title will be snake case sprite underscore 2D, while here we'll have capital case, capital S sprite 2D. Just to make that clear. So that's the important to actually understand what is going on during the, so Godot workflow is a lot of UI elements, but and GDScript and combining those, but how to keep track and how the user interface links that together and presents it to the developer. That's an important exercise. I take this as an exercise for that. To learn how to keep track about references for the objects, nodes, game elements, and how they are bound to scripts or related to our script. Currently doesn't do anything. Let's make it print the text hello world to the output button panel. To get started, add a following code to your script. I'm just curious how it looks in the C#. And why would I even try to use C#? But I don't need an answer for that. No, I'm not looking for an answer to that question. GDScript function underscore init print hello world. Let's break it down. The function keyword, we'll learn that in the learning from zero course. Keyword defines a new function name init. This is a special name for our class constructor. The engine calls underscore init or initialization on every object or node upon creating it in memory if you define this function. GDScript is an indent-based language. The tab, okay, we'll learn that. If I omit it or don't ident a line correctly, the editor will highlight it in red and display the following error: indented block expected. Save the current scene as sprite2d underscore 2d.tscn if I haven't already, and run with F6. Run the scene, not the project. So I will print function, type in function right here. I'm not still super clear about the Or is it FNC just? No, function. Huh? Function print. What was it? Print saluti di tutti. And I save the scene. Well, if I press Ctrl S, it will save. Selected. Save a scene as. Should I double check? Okay, saves. This is the default. So it helps me by suggesting a file name as a keeping the name reference to the scene, current scene. And I can run the scene. Here is this thing. It's a little bit too large for my taste, but we are supposed to have here, where is it? Okay, so here it is in the out, so here is the output. I've clicked on it to expand it so we can read here. And here is the message I wrote. I will close this, F8. And next step. So I just want to see if I can get clearer. If I get clearer insight into the init function. I understand the function name init. This is a special name for our class constructor. The engine calls. So I'm assuming that the init initialization is will appear for every scene. If I define this function, so everything can have this function. That's my assumption. It's not just like in other, let's say in C++ there is only one initialization entry point for the application. Next step, I've saved the scene, and yeah, output is that. Delete the init function, so you're only left with the line extends sprite to the turning around. It's time to make our node move and rotate. To do so, we're going to add two member variables to our script: the movement speed in pixels per second and the angular speed in radians per second, and the following after the extends. Add the following after the extends sprite line: speed 400, angular speed equal pi. Member variables sit near the top of the script after any extends line, but before functions. Every node instance with this script attached to it will have its own copy of speed and angular speed properties. So they say that I should delete this, but no, I will just comment it out and use this and say var speed equal 400, like suggested, variable angular speed equal pi. And here is the here is the smart intelligence. Back to the documentation. Speed, angular speed, member variable sit there. Angles in Godot work in radians by default, but you have built-in functions and properties available if you prefer to calculate angles in degrees instead. To move our icon, we need to update its position and rotation every frame in the game loop. We can use the process function, virtual function of the node class. If you define it in any class that extends the node class, like sprite2d, Godot will call the function every frame and pass it an argument named delta, the time elapsed since the last frame. Games work by rendering many images per second, each called a frame, and they do so in a loop. We measure the rate at which game produces images in frames per second, FPS. Most games aim for 60 FPS, although you might find figures like 30 on slower mobile devices or 90 to 240 for virtual reality games. The engine and game developers do their best to update the game world and render images at a constant time interval, but there are always small variations in frame render times. That's why the engine provides us with this delta time value, making our motion independent of our frame rate. At the bottom of the script, define the function process delta rotation plus equal angular speed times delta multiplied by delta. Function process delta rotation. Was there a angular speed? The function defines a new function. After it, we have to write the function's name and arguments. It takes in parentheses a colon ends definition. So we know that from the learning course, and the indented blocks that follow the function's content or instructions. Okay, so notice how process like underscore initialize starts with a leading underscore by convention. Godot's virtual functions, that is to say built-in functions you can override to communicate with the engine, start with an underscore. By convention, I will repeat. Godot's virtual functions, that is to say built-in functions you can override to communicate with the engine. Built-in functions start with an underscore. So the underscore process, underscore init, they exist, and it's possible to override them the default behavior and implement add our own code to behavior. But they exist in the engine by default, because this is already a built framework to do a specific task. The line inside the function rotation plus angular speed increments our sprite's rotation every frame. Here, rotation is a property, so this is important. Rotation is an existing inbuilt property inherited from the class node2d, which sprite2d extends. It controls the rotation of our node and works with radians. Let me give me a shot at that. I'm multiplying, adding a rotation, incrementing rotation, radians of the rotation by angular speed times multiplying it by delta. Okay. So I will create function or call the process. Yep, I can use this tool to autocomplete, and I squeeze these things so I can see the full line, and it is an existing property plus equal angular speed autocompletion using learn to use the tools provided delta right away like that. And if I switch back to the browser, the line inside the function, okay, increments our sprite's rotation every and takes radians. Tip: in the code editor, you can control click on any built-in property or function like position, rotation, or process to open the corresponding documentation in a new tab. In the code editor, run the scene to see the Godot icon turn in place. Cool. So F6 to run this scene. There he goes, here he goes. Times delta. Cool. What's next? At the moment, sorry about if it's annoying me moving the screen every time, but this is the best. At the moment I have to make the fonts larger without messing up everything and actually zooming into what I'm doing, so you can see clearly on most screens, up to the mobile, I hope. In C#, jump over that for now. Well, in C#, notice how delta argument taken by process is a double. We therefore need to convert it to float when we apply it to the rotation. So I'm guessing that in GD script it's the float by default. Double, that's I think double type refers to just a numeral type with 2 decimal places. I'm not super sure right now. More info can be found in the class reference and GDScript documentation. Let's now make the node move. Add the following two lines inside of the process function, ensuring the new lines are indented the same way as the rotation. Okay. These two lines. So I'm supposed to create a variable velocity, which will be equal to vector 2d up rotated by rotation times speed. Position plus equal velocity times delta. Okay, so as we already saw, the var keyword defines a new variable. If I put it at the top of the script, it defines a property of the class. Inside the function, it defines a local variable. It only exists within the function's scope. We define a local variable named velocity, a 2D vector representing both a direction and speed. How? And how is that performed? Vector 2 up rotated rotation. We define a local 2D vector. To make the node move forward, we start from the vector 2D class constant, vector 2 up, a vector pointing up, and rotate it by calling the vector 2 method rotated. This expression, vector 2 dot up dot rotated past rotation to it, is a vector pointing forward relative to our icon. Multiplied by our speed property, it gives us a velocity we can use to move the node forward. Well, I guess there is, since vector contains two sub-variables, it has a sub-members, so this expression vector 2 dot, this expression has the engine has also using the implementation about the vectors, what's it called, arithmetics calculation for both of its sub-members, which is a speed and, well, anyway, it derives, we get those two sub-members updated with this expression. Multiply this with speed by our speed property, it gives us velocity we can use to move the node forward. We add velocity times delta to the node's position to move it. The position itself is of type vector 2, a built-in type in Godot representing a 2D vector. Let me get this sync in the head. We defined a local variable velocity, a 2D vector representing both a direction and speed. Okay, direction and speed. To make the node move forward, we start from the vector 2 class constant, a vector pointing up, and rotate it by calling the vector 2 method rotated, up rotated. This expression vector up to rotated rotation is a vector pointing forward relative to our icon. Multiplied by speed property, it gives us a velocity we can use to move the node forward. Rotation. I'm just making sure that actually I understand this part and what's going on here. Stop jerking around. We are passing the rotation value. Rotation. So we are passing the value of inbuilt rotation, which is it mentioned that it is also a vector? Is it mentioned here that it is a vector? What is the rotation? It doesn't mention that. Rotation, here rotation is a property inherited from the class node 2D. Okay, so I could check the documentation. Let me check. I want to see, let's learn about the rotation. Where is it? Rotation. Where can I learn about it? Back to this. I do what to learn? What's the shortcut? This time give me a shortcut. Control click. So if I control click on the rotation, it will open a documentation. Before going forward, let me check that. So control click on rotation. Here it is. So it's a float. It's a float. Vector 2 position. So what is this? Transform. Float rotation. Okay, that's the type. Set rotation, get rotation. Rotation in radians relative to the node's parent. Note this property is edited in the inspector in degrees. If you want to use degrees in a script, use rotation degrees. Okay. Back to script. I guess this is showing the link reference open to the node2d class reference members, like a rotation. I might just take this for granted, take it as it is, but it is important to understand. I want to understand the physics, how this physics is implemented, this angular movement, because there is already a built-in library to solve those calculations. I don't need to implement again, reinvent the hot water, implement my own angular movement and how to integrate it. New integration. It's already, the class is all built, but I just want to align my logic with what is already available here. So I'm supposed to create the variable velocity, and it is a vector 2 up, rotated by rotation times speed. Position is velocity times delta. So we will update the position. Okay, velocity times delta. Why is it using rotation times speed? Degrees, okay. I want to exercise my ability to memorize, the skill of memorizing code text, but exercise the logic to use the ability skill to create the code, applying the suggested logic. That's why I'm taking time. I don't just literally to type copy of this. I want to logically understand it, or cognitively understand it, and implement that. Do that implementation with the coding skills so far I acquired to implement this. So I'm creating a velocity that is actually used to change the position, and velocity will need this vector 2, and it is changing by rotation. And how is the vector up? I might expect even spiral movement, but spiraling movement. Vector up rotated by rotation. I have that in the code, and speed. So vector up rotated. Okay. So variable velocity is equal to vector 2 dot up. There is a code hints I can use. That's nice. And rotated, rotation, the rotation that we already have here, times times the speed. So I'm using the set speed, which is our custom. What am I getting? So probably the warning is given. I created velocity that I didn't use so far. Now I'll use it. So I'm updating the member variable position here in the process. So plus equal velocity times delta. Was it that? Yeah. So position is increased by addition, but the value added is changing non-linearly. That's good, because angular movement is completely different to get it calculated than just linear addition. Run the scene. Okay, let's run the scene. Let's make a scene. please. Do behave. F6. Okay, lovely. Lovely and somewhat understood. But I don't think that is in the right position. And why is that? Why would this be over here? F8. Did I close that? Can I see? Okay, run the scenes, check the code. That's good. Next step would be moving a node like that doesn't take into account colliding with walls or the floor. In your first 2D game, you will learn another approach to moving objects while detecting collisions. Our node currently moves by itself. In the next part, listening to player input, we'll use player input to control it. Complete script 1. Here is a complete script file for reference. Okay. And with our in the stream, our 10 minutes, 11, time to for a short break. I'm just reading about this comment. There's some let's see. There's a better way to do this in Godot. I simply evaluated the derivative of the position vector of an object in a circular motion. My hand and heart. Something I think is missing from this doc. Not sure if this qualifies for an issue to be raised. Is an explanation of how sprite 2D GD works to rotate the sprite, something like this. Yeah, so this is like a more elaborate the physics logic in behind it. Yeah, so I think you're this is not there. So this is his the comment is about the implementation of the sprite 2D, but sprite 2D is specific use case in 2D, and that's what the use case is for. He went as a more with more math and physics background into elaborate how to graph movement and speed. But the implementation he suggests is for use case where we don't have already tool functions provided for the specific task. They can be applied for the engine, for the game logic to keep a track of what the, to let's say, build an algorithm in game to help game logic to predict the engine behavior. Okay, short break. The outro. Stay safe. See you soon.